Today we're going to start reviewing for our Chapter 4A test. We have two learning targets that deal with graphing. The first is to identify and graph quadratic functions in vertex form. And the second is to graph them when they are in standard form. So if you remember, vertex form is that one that looks like our transformation formula. So we're looking at H and K being the vertex, and our A value tells us if it opens up or down. It tells us if it's stretched or compressed, that kind of transformation. Okay? Clean that up a little bit here. All right, so when we look at our first example, we have y equals the quantity x plus 1 squared minus 3. If we identify our transformations, we are moving left 1 and then down 3. So on our graph, let's start with our parent function. Remember, the parent function is just y equals x squared. So we're squaring our x coordinates, and squaring negative 2 or positive 2 gives us a 4. Squaring a 1 or a negative 1 gives us 1. Squaring 0 is 0. So picture having our points 0, 0, 1, 1, 2, 4. And then negative 1, positive 1, and negative 2, positive 4. So that's our parent function points. And we're going to shift all of those points left 1 and down 3. So our vertex is going to move left 1 and down 3, and it's going to land over here at negative 1, negative 3. Our axis of symmetry is going to go right through that x coordinate, so it would be x equals negative 1. Make sure you have it as an equation. If we move our other points left 1 and down 3, we get our red parabola. So we're going to connect those in a nice smooth curve. Because our parabola opens up, we have a minimum value. The lowest y value that we ever get to is the one at our vertex at negative 3. Our domain for quadratics, parabolas, is always all real numbers. And our range is based on that minimum value. Since negative 3 is the lowest we get, our y's have to be greater than or equal to negative 3. All right, our next two examples are in standard form. That's that ax squared plus bx plus c. So in order to find our vertex and axis of symmetry, we have to use that equation x equals the opposite of b over 2a. So in example 2, our a value is 2, our b value is negative 4, and our c value is negative 5. So let's calculate x. We want the opposite of negative 4, so positive 4, and we're dividing by 2 times our a value. So we really end up with 4 divided by 4, or 1. That tells me my axis of symmetry is going to be at 1. And my vertex is going to have an x coordinate of 1. Now to find the y coordinate, remember we plug that x value in. So we're going to take this 1 that we got and plug it into our x pieces. So we have 2x squared, so 2 times 1 squared, minus 4 times 1 minus 5. 1 squared is 1, times 2 is 2. Negative 4 times 1 is negative 4. So we have 2 minus 4, which is negative 2. Subtracting another 5 puts us at negative 7. So my vertex is going to be at positive 1, negative 7. Now, our a value was a positive 2, so our graph opens up, which means we have a minimum at negative 7. So our y values have to be greater than or equal to that. Our domain, again, is always all reals. Now, to get our coordinates for the other points, we made a table and we looked at our vertex was at 1, negative 7. We found the y-intercept, which is what we get when we put 0 in. we're just going to end up with our constant term of negative 5. So let's go ahead and plot 0, negative 5. We can reflect it over the line of symmetry. And then we're going to find one more point. Let's go ahead and put a negative 1 in. That's close to our other dots, our green dots. So if we put a negative 1 in here, we have 2 times negative 1 squared minus 4 times negative 1 minus 5. Negative 1 squared is still 1 times 2 is 2. But negative 4 times negative 1 now is going to be a positive 4. So we end up with 6 minus 5, which would be a 1. So at negative 1, we are up here at positive 1. And again, we can reflect that over our line of symmetry. So we are 2 spaces to the left. We're going to go 2 spaces to the right. And then again, we're going to draw that parabola in. Nice smooth curve. All right, you guys pause the video and try the next one. All right, looking at this one, notice that our a value is negative 1. So our parabola should open down, which means we're going to have a maximum. Let's go ahead and figure out our our x coordinate of our vertex and our axis of symmetry. So we need the opposite of 2 divided by 2 times our a value. So 2 times negative 1 is negative 2. We have negative 2 divided by negative 2, so we end up with x equaling 1 again. All right, our vertex then would have an x-coordinate of 1. We need to find our y-coordinate. I didn't leave myself a whole lot of room here. So our y value is what we get when we put a 1 into that expression. So we've got negative 1 squared plus 2 times 1 plus 3. So 1 squared is 1. The negative in front makes it negative 1. 2 times 1 is 2 plus the 3. Negative 1 plus 2 is 1 plus 3 is 4. So we have a maximum value at 4. Our vertex is going to be at 1, 4. Our parabola should open down. Let's go ahead and make a table. We have a vertex at 1, 4. We have a y-intercept when x is 0, and we just get our c value of 3. We can flip it over the line of symmetry, reflect it over to get the other side. And then let's go ahead and put in, we can either use negative 1 or positive 3. Let's go ahead and try 3 this time. If we put a 3 in here, we've got negative times 3 squared plus 2 times 3 plus 3. 3 squared is 9. This will make it negative 9. Plus 6 plus 3. We end up with 0. So at 3, we're at 0, right on the x-axis. Reflect that over the line of symmetry, and then draw in the parabola. Domain is always all reals. And range, remember, is based on your max or min. Our max is 4, so our y values have to be less than or equal to 4. All right, the next topic that we looked at was how to find all of this information without actually graphing the whole thing. So we have an equation again in vertex form. Looking at the transformations, our 2 in front caused a vertical stretch of 2. The 3 moved it left 3, and the negative 5 went down 5. So if you picture moving left 3 and down 5, our vertex is going to be at negative 3, negative 5. That means our axis of symmetry is the equation x equals negative 3. Our a value is 2. We did not reflect this over the x-axis, so our parabola should open up, which means we are going to have a minimum of negative 5, our y-coordinate of our vertex. Domain is always all reals, and since negative 5 is a minimum, we're going to say the range is everything greater than or equal to negative 5. All right. You guys pause the video and try this next one. All right, analyzing our transformations. We have a -3 in front, that's our A piece. So that means we have reflected this over the x-axis. We've done a vertical stretch of 3. The subtracting 2 inside our parentheses means we've moved it right 2, and we have moved it up 7. So right 2 up 7 puts my vertex at the point 2, 7. My axis of symmetry then matches the x-coordinate. My max and min matches the y-coordinate. Since we've reflected this, it's an upside down parabola, which means we have a maximum of 7. So my range is going to have to be less than or equal to 7. Y is less than or equal to 7. And again, my domain is always all reals. All right, so that's a review of graphing. Question 6 says, for physics class, Osseo Senior High School had a pumpkin flinging contest on the football field for Halloween. The catapult stands 4 feet tall. The height h of the pumpkin in feet can be written as a function of time t in seconds, as h equals -16t squared plus 36t plus 4. We want you to show or explain how you get your answers. The first question says, when did the pumpkin reach its maximum height? So our y value was height, h, and our x-coordinate was time. So our starting height is 4, our constant. So we're starting here at 4, and they're going to shoot that pumpkin up in the air, and eventually it's going to come back down. To find the place where it reaches the highest point, we need to find the vertex. Now the first question says, when did it happen? So we're looking for time. We're looking for the x-coordinate, or t in this case. So t equals the opposite of b over 2a. Our b value is 36, so we need -36. And we're dividing by 2 times -16. So -36 divided by -32 comes out to be 1.125 seconds. Then it says, what is the maximum height? This time they're looking for what is the height. Now we want the y-coordinate of our vertex. So we need to plug in our x value into our equation to figure out our height. So -16 times our time, 1.125 seconds, squared, plus 36 times our time, 1.125, plus 4. Go ahead and grab your calculators. We should end up with a height of 24.25 feet. Then it says, if the pumpkin strikes a post that stands 4 feet tall, how long was the pumpkin in the air? So instead of it coming all the way back to the ground, we're wanting it to stop at the same height that it started. This just means that we need to figure out the x value that takes us to the middle and then double it because of the symmetry. Well, we already found how long it takes to get to the middle. So we just need to double that. So 2 times 1.125 gets us 2.25 seconds. All right, moving on to section 4.4. This is where we looked at factoring trinomials, or some of our special patterns. Our first one says x squared plus x minus 42. We are factoring the x squared into x times x. We need two numbers that multiply to be -42 and add up to 1. Now we have several pairs that give us a 42. We could have -1 and 42, or the opposite. We could have -2 and 21, or the opposite. We could have 3 and 14 with one negative. We could have 6 and 7 with one negative. And since we're trying to get to a positive 1, this -6, positive 7 will be the option we need to pick. All right, question 8. We have 16x squared plus 56x plus 49. We have a couple different ways that we can split up our 16x squared. We could do 16 and 1, we could do 2 and 8, we could do 4 and 4. Notice that the first term is a perfect square, and so is the last term. So seeing that, I'm going to check to see if this is what we call a perfect square trinomial, and look at how we can split those up into equal pieces. So the 16, if we think of it as 4x and 4x, our 49 we can think of as 7 times 7, and if we check our insides and outsides, we've got 28x plus 28x. That will get us the 56x in the middle. If you have two terms that are identical, we could write this just as 4x plus 7 quantity squared. Either option is fine. For question 9, notice that it starts with a negative. Let's go ahead and pull that out. Think of that as your GCF. Take a -1 out. We have t squared plus 3t minus 18. And now we're going to factor that. We're back to just a t squared, so we'd have a t in each piece. To get a -18, we can have -1 and positive 18, or the reverse pair. We could have -2 and 9, or the reverse. And we could have -3 and 6, or the reverse. To get a positive 3 in the middle, we would need to use the -3 and the 6. All right, for question 10, notice that all of your terms have an x, so we definitely want to factor that out. Also notice that we could divide a 5 out of everything. If we take a 5x out of all of it, we'd have a 2x squared plus 7x plus 3. And then let's try to factor that trinomial. So our 2x squared, we'll think of splitting it as 2x and x. To get a 3, our only combination would be 1 and 3. And we're trying to make a 7. So if we put the 3 on the outside, we get 6x for outsides and 1x for insides. And that would add up to the 7 in the middle. So our answer would be a 5x, a 2x plus 1, and an x plus 3. For question 11, we do have a GCF. We could divide a 25 out of all of that. That would leave us x squared minus 4. And x squared minus 4 is a difference of squares pattern. It factors into two almost identical factors, except one is a positive and one is a negative. That's why we don't have a middle term. They cancel each other out. Now, just a comment about this one. If you had left it as 25x squared minus 100, we could have factored it into 5x minus 10 and 5x plus 10. But that's not as factored as it can go, because we could have pulled a 5 out of each of those. And that 5 times 5 would end up becoming our 25 that we have here. So what I did originally in the red pen is your best option. It's as factored as it can go. All right, go ahead and pause the video and try this last one. All right, let's check your work. We have 5x squared. We're going to split that into 5x and x. To get a -2 as our constant, we need a 1 and a 2 with one of them being negative. We want to get a positive 9x in the middle. Whatever we put here is going to get multiplied by the 5 when we do outsides. So if we put a 2 here, we are going to make this 10x on the outside. So if we make the positive go with the 2 and the negative with the 1, we can get a -1x in the middle, insides, and a positive 10x for outsides, which would add up to our 9x that we were looking for. Now notice that those 6 examples we just did were just expressions, quadratic expressions. We didn't have it equal to anything, so all we were doing was factoring. But in the last section of questions here, we are trying to solve it. So notice that it does equal 0, which means we're going to factor and set each of those factors equal to 0 using that zero product property. Our first one is x squared minus 49. That's a difference of 2 squares. So we're going to factor it into x plus 7 and x minus 7. And then we set each of our factors equal to 0. So x plus 7 could be 0, or x minus 7 could be 0. To solve that, we're going to subtract the 7 over, and on the second one, we're going to add the 7 over. So we get an x value of 7 or negative 7. For question 14, we have 3x squared minus 10x minus 8. There's no common factor that we can pull out. So let's go ahead and split up our 3x squared. We'd have 3x and x. To get a negative 8, we have a few options. We can use 1 and 8 with one of them negative, or we can use 2 and 4, again with one of them negative. And we're trying to get a negative 10 in the middle. So picture whatever we put on the outside here is going to get multiplied by that 3. So if we put a 4 here, we will create a 12x. The 2 here would make a 2x in the inside part. And since one of them has to be negative, to have them add up to a negative 10, the 12 would have to be the negative. And following that through, that was our outside piece, so the 4 would have to be negative, and the 2 would have to be positive. Now, it still is equal to 0, so once we know that we have the correct factors, we're going to then set each of those factors equal to 0. So 3x plus 2 could be 0, or x minus 4 could be 0. And then we solve for x. We can subtract 2 and divide by 3. So negative 2/3 is one option. Here we're just going to add the 4 over, so 4 is the second option. All right, we've got x squared plus 2x minus 15 equals 0. Again, we're going to break up our x squared into x and x. We need two numbers that multiply to be a negative 15. So we've got the 1 and 15 pair, or the 3 and 5 with one negative. We want it to add up to a positive 3. So let's pick the 5 with the negative 3. So a positive 5 and a negative 3. Then we set each factor equal to 0 and solve. So subtract the 5 gets us negative 5. Adding the 3 gets us a positive 3. All right, looking at our next set. We have 9x squared minus 30x plus 25. 9x squared we could factor into 9x and x, or 3x and 3x. 25 we could use 1 and 25, or 5 and 5. Since they're both perfect squares, I'm going to try the pairs that match. So I'm going to use the 3x and 3x, and I'm going to try the 5 and 5. Now, we need a positive 25 for a constant, but notice that we need a negative 30 inside. So we really are looking at the pairs with two negatives. And let's check this. We get a negative 15x inside, and we get a negative 15x on the outside. That gets us our negative 30x. All right, once we've got our factors, we have it still equal to 0. Now notice that both of these are the same, so we really just have to solve it once. We're going to add the 5 to the other side, and then divide out the 3. All right, go ahead and pause the video and try the last two. All right, let's check your work. X squared minus 25 equals 0. That is a difference of squares pattern. So you should have factored into x plus 5 and x minus 5. Setting each of those equal to 0, we end up with x being a negative 5 or x being a positive 5. Our last one, we have 4x squared plus 36x plus 81. Again, 4x squared, we could split that into 4 and 1 or 2 and 2. 81, we have lots of combinations. 1 and 81, 3 and 27, 9 and 9. And since both the 4 and the 81 are perfect squares, let's try to see if we can get it to work with the ones that match. So let's try 2x and 2x and the plus 9 in each one. It still is equal to 0. Inside we get 18x, and outside we also get 18x. That would add up to our 36 in the middle. So this is another one where we get two identical factors. It's called a perfect square trinomial. So setting them both equal to 0 gets us the same answer. We're going to subtract 9 and divide out the 2. So negative 9 halves.